about them. We spoke about some of the things that are related to them, such as which ones respond to chemotherapy, which ones do not. Anything else? Anything else? Shall we name them? What are they?
Bacteria, viruses,
Fungi,
viruses, algae,
Rickettsia,
protozoa,
protozoa. That's it.
Okay, so everybody can get those 5 right out. What were the
Protozoa,
other 2?
protozoa,
mice,
and the mycoplasma.
Protozoa. And the last one?
Mycoplasma.
Right. I was trying to show you that in that group of 7, that there are multiple times that these organisms can cause problems. When we spoke about pneumonia, we said that you can have a bacterial pneumonia, you can have a mycoplasma pneumonia, and a viral pneumonia. You don't get pneumonia, but you can get lung infections with fungi. So you get a lung infection with not a pneumonia. Hello. And this would be Robert something?
That's right, Robert something?
Yeah, I gotta find something. Robert what?
Go ahead.
Oh, he's gonna make me look on the wrong thing. Oh, Robert. Yeah, that's it, thanks. Okay. Anyway, I would kind of try to remember those groups because we looked at the ones that would respond to chemotherapy, correct? Correct. And we said that not the same chemotherapy would be used among them. There would be different types. You don't take an antibacterial if you have a fungal infection, let's say. Well, there's another component here that is somewhat interesting, and it has to do with cellularity. And that is that not all of these, number one, are cells, and not all of these are very advancedly developed cells. Some of them are very primitive cells, so we need to, at a point, to differentiate between those that are prokaryotes. Those are the very, very primitive cells. Wait, you're sneaking in, not sneaking, but name?
Annalisa, Maria?
Okay, thank you. Those that are very primitive cells and those that are advanced cells. The very primitive cells are prokaryotes. The fully developed cells are eukaryotes. And I'm going to go into this in great detail in the future when we talk about how these cells function, because that tells you how everything behaves. But this is the cell that has the true nucleus. I'm going to emphasize this a lot later on. The prokaryotes have no nucleus, which means they're very primitive. And the thinking is that they would have been the ones that came first in the evolution of organisms. That those prokaryotic cells were very primitive, also very primitive in function, because remember something from anatomy, structure always defines function. Structure always defines function. They're very tightly tied together. And then, in that group, there are non-cellular structures. They are not cells at all. So let's see how that would play out. Bacteria are prokaryotes. They are the ones that are very primitive. And as we're getting ready to start our history, bacteria existed 3.5 billion years ago. Imagine that, 3.5 billion years ago. I actually was not there at the time. And what we know and how we know it fossil evidence of spores. They have seen fossil evidence of spores. And if you think about the other thing we said yesterday, or Tuesday rather, in terms of dimorphism, bacteria have the vegetative form, which is actively metabolizing, and then they have the spore form. The spore form is non-metabolic. Nothing is going on in the spore. It just is. So it's sort of like the dinosaur DNA that they found in amber, that they think they can recreate animals from. You've got the core of the organism, but it's not doing anything. So that's the very first evidence that we even had bacteria around. And that's kind of amazing when you think about it, because they're still here. And we, if you think about when we arrived in the world, and give me a name.
Greg.
What?
Gabar. First sheet. Gregory Gabar.
Okay, thank you very much. If you look at a clock, and a lot of times people do that, they look at the clock of the world, the history of the world, and they say that man arrived 1 minute to midnight. If you compressed it into a 24-hour clock, man would have arrived 1 minute before midnight in our whole collective history. So I'm saying that bacteria existed 3.5 billion years ago. Wow, that's amazing. It's amazing that they've existed that long without going into extinction. And it's also amazing that they're very, very simple. More complicated structures have been around for a while and then disappeared. The dinosaurs were very complicated, and we don't have them anymore today. So the forces that supported the simple organisms have existed for 3.5 billion years, and the forces that did not support the complicated organisms have gone away. So we look at our climate and we say, well, are we ever going to go back into an ice age? There's some thinking about that. Scary. I probably won't see that either, so I'll just enjoy the fall weather. Okay, so the bacteria are prokaryotes. The fungi are eukaryotes. They have a nucleus, and the nucleus directs their cell function and is a very significant part of the cell structure. Viruses have no cell structure. They are acellular. They're acellular, which is why we identified them yesterday, or Tuesday. I keep saying yesterday. I guess I was dreaming about you yesterday. Well, Tuesday we said that viruses were obligate intracellular parasites. And the reason for that is they just don't have enough juice, if you will, to do everything themselves. They have to rely on other. Name first before you sit down.
Goldman, Jessica.
Last name?
Goldman. Would it be?
Yep. Now, you were not here on Tuesday, correct? Jessica, come here, please. This is the syllabus for the course. We went over that on Tuesday.
Okay.
And you are? Say it again.
The door's locked.
All right. Hello. Oh, wait, you opened the door and people already? Hold on.
Sorry about that.
It's still loud.
And you are? Did you come in last time? You weren't here Tuesday? All right. Did you read? And you say
For the virus, I don't know, I just this is something over here.
All right, we're still looking for Tanisha Hart.